Okay, so now that we've worked with our compound interest, we're going to talk about continuously compounded interest. So let's consider an investment of $1 in an account that pays a 100% annual interest rate for 1 year. So we're just coming up with an example that uses ones just to make the math of this easy. The equation A equals 1, that's the initial investment, times 1 plus 1 over n times, there's the 1, the r, 100% annual interest rate will be 1 times n times 1 for 1 year. This equation simplifies to this, 1 plus 1 over n raised to the n. So we just tried to get a simplified equation, so that's why we used $1, 100% annual interest rate for 1 year. We want to take a look at finding the total value of the investment after different number of compounds per year. So we're going to start out with just one compound per year. So what happens if n is equal to 1? You have 1 plus 1 over 1 raised to the first power. And if we do all that math, grab your calculator, see if you get the same thing, we get a 2. All right, well, what if n is a 10? So we have 1 plus 1 over 10 raised to the 10th power. So we're compounding 10 times a year. We get 2.59. If n is 100, 1 plus 1 over 100 raised to the 100th power, we get 2.70. What if n is 1,000? So that's a lot of compounds in a year, right? We're just calculating interest like crazy. Raised to the 1,000 power. When we do that, we get 2.7169. How about 100,000? 1 plus 1 over 100,000 raised to the 100,000 power. Grab your calculator. See if you guys can calculate this out the same way I have. 2.71826. Oh, that's 100,000 twice. I think that's a typo. Well, why don't we get rid of the last one? Okay, so what is happening here? As we increase the number of compounds per year, like 100,000 compounds per year, 365 days divided by 100,000 compounds. I mean, how many times are we calculating the interest in a year? So what we notice is that as n continues to increase, n is our number of compounds per year, the value of the account remains very close to $2.718. And that could continue. But if you notice, as we increased our number of compounds, and we're getting, like, that's a lot of compounds in a year, our number is not getting huge, right? It's just getting more and more refined, getting closer and closer to this 2.718, and that number could continue. So that leads us, because this number exists with this continuously compounding idea, if you just compound constantly, we get to a number that we call E. So E is kind of like pi. You know, pi is just, it's a number that exists, that is common, so it gets its own little symbol. Well, welcome to Algebra 2. Here's another one. This is like E. We have it's called the natural base, E. So as x, as x approaches infinity, 1 plus 1 over x raised to the x power, that's ultimately the math we were doing up here, that approaches 2.718. And that number, we could write out more of it. So E, the mathematicians gave that a name. They said, okay, well, we keep approaching this number, so we're going to call that E. So E is equal to 2.718 ... This is on your calculator. See if you guys can find where your E button is. The number E is irrational. Just like pi is irrational. And it is the base in the continuously compounded interest formula. Well, what is that? What is that formula that you speak of, right? Well, let's write in. We have a formula that if we are going to continuously compound our interest, which means we're just going to calculate it all the time, okay? There's a formula, let's not use a highlighter. A equals P times E raised to the RT power. So when we say that the number E is irrational and it's the base in this formula, here it is, it's a base with the exponent RT. So why don't we go ahead and write out what all those stand for. So P is our initial principal invested. E is the natural base. R is our annual interest rate. And then remember that will always be written as a decimal. It's that percent value. T is the number of years. And A is the value of the account after T years. So you guys are going to have a couple formulas dealing with compounding interest. If you're compounding quarterly, that's a formula from the other video. If you're compounding continuously, this is the formula you use. So the key word is continuously right here. You might hear some people say A equals PERT, P-E-R-T. The PERT formula, that's for continuously compounding interest.